All right, welcome to The Explainer. Today, we're diving into one of the most hostile, most dangerous environments on our planet. And we're going to look at the incredible life that's not just surviving there, but actually thriving.
For almost 4 decades now, the word Chernobyl, it hasn't just been a place, right? It's become a symbol of catastrophe, a ghost city that stands as this chilling monument to human error.
But what if I told you that this place, this exclusion zone, has become something else entirely? A living, breathing experiment that's rewriting the very rules of evolution right in front of us.
I mean, listen to how our source material describes it. This place of death has literally become a cradle for accelerated evolution. Okay, so let's really get into this.
So let's just recap the timeline real quick. It all kicks off with the disaster in '86, and the whole area is sealed off. For decades, while humanity was figuring out how to contain the mess, which led to that giant arch in 2016, something else was happening. In our absence, nature didn't just hang on. It started to adapt in ways that are just, well, stunning.
And that right there, that's the core paradox of Chernobyl. It's a place where life isn't just resisting this lethal force, this constant radiation, but in some cases it seems to be actively using it.
I mean, the things scientists are finding in the zone, it's like something out of science fiction. You've got these tree frogs that literally change their skin from green to black for protection. You've got wolves that have evolved cancer-resistant immune systems. And then there's the most mind-blowing discovery of all, fungi that seem to be eating the radiation.
Right. So the big question is, how? How on earth is any of this possible? And the answer, unbelievably, comes down to a molecule we all have, melanin. And this is a question that should make anyone in biotech just stop and think. How can a living thing literally feed on gamma rays? This completely challenges our fundamental understanding of metabolic pathways.
Okay, get this. We all know how photosynthesis works, right? Plants use the pigment chlorophyll to grab sunlight and turn it into energy. Well, think of this as its hardcore cousin. Instead of chlorophyll, these fungi use melanin. And instead of sunlight, they're using gamma radiation. They're calling it radiosynthesis, and it's a total game changer. You know, we usually just think of melanin as pigment, the stuff that gives color to our skin and hair. But in this context, it's so much more. It's acting like a biological semiconductor. It's this incredibly elegant piece of organic tech, managing high-energy physics right at the molecular level. And the process itself, it's just so brilliantly efficient. A gamma ray zaps a melanin molecule. The melanin doesn't get destroyed. It absorbs that chaotic energy and spits out a controlled stream of electrons. Those electrons get plugged right into the cell's existing power grid, firing up the same ATP synthase engine that powers you and me. It didn't reinvent the wheel, it just found a brand new and kinda terrifying fuel source.
But you see, this goes way beyond just survival. It points to a really deep principle, what our source calls energetic opportunism. It's this idea that life, as a force, is relentless. It will find any available energy source in the universe and figure out a way to colonize it.
And it's not passive either. The fungi actually show something called radiotropism. That means they actively grow towards the radiation. Think about that. Just like a sunflower twists to face the sun, these fungi are seeking out the most radioactive hotspots. For them, radiation isn't a danger, it's dinner.
So when you see a life form turn a destructive force into food, it makes you wonder if there's something bigger going on. It really suggests that there's a fundamental force in living things that runs completely opposite to the decay and chaos we see in the rest of the universe.
Yeah, we all learn about entropy in school, right? The second law of thermodynamics. Everything breaks down, falls apart, moves toward chaos. But Chernobyl is like a giant glowing billboard for its opposite, syntropy. This built-in drive toward order, toward complexity, toward life.
Our source material actually gives this ordering principle an ancient name, logos. The best way to think about it is like it's the universe's operating system. It's the underlying code that allows energy to be organized into complex structures, whether it's a star or, in this case, a fungus that can eat radiation.
And this leads to a really mind-bending idea. The reason anything can evolve at all is because nothing is ever perfect. The circle of existence never quite closes on itself, and that tiny little gap, that imperfection, is where all the new stuff comes from. This slide is a fantastic way to visualize that.
The source calls it the pista mirabilis, the miraculous track. It's this idea that matter itself is just energy, trapped light, moving in a spiral that never ever lands in the exact same spot twice. It's like the number pi. It just keeps going without repeating. And that constant, tiny bit of newness, that's what makes life and evolution possible.
Okay, so this is all incredibly fascinating, but it's not just a philosophical rabbit hole. It might actually give us a blueprint for a whole new way of building our world.
And that's really the big takeaway here, isn't it? If nature can figure out how to turn nuclear waste into a life-giving resource, can we learn to do the same? Can we start designing things that don't just fight against decay, but actually harness it?
I mean, just imagine this for a second. Our cities, which are basically these giant heat islands just bleeding wasted energy, what if we could coat them in a kind of synthetic moss that works like melanin, a skin that just soaks up all that waste heat, all that ambient radiation, and turns it into clean, usable electricity? Our cities could cool themselves and power themselves.
And that really brings us to the final and maybe most important question. The Chernobyl fungi have shown us that nature can take our most chaotic toxic mistake and turn it into food. It makes you wonder, what other messes have we made? What other problems that we think of as dead ends are actually just the raw materials for the next stage of evolution?